convenient. I would say that is the most convenient explanation for a lot of the people involved, especially people in power. What it does fit based and working with some other investigators that have said the same thing independently. Lithium battery fires occur at almost that exact time frame in terms of after departure. Well, there's just really no evidence to support it. I mean, that's all built around, a pilot having a flight simulator, and dipping and climbing is, it's a much more closer to what we see with a phugoid type of motion. The airplane, if it is coupled to flying the flight management system, is following basically what we call the magenta line. You look at how they were all interacting, and in a causal analysis based on system theory, or a CAS, we try to understand why the controls that they had in place did not work. In the ocean, they almost always, even if it's controlled, the airplane usually ends up cartwheeling.
Good morning, good afternoon, and good evening to our audience from around the globe. This is your host, Sid, and it is wonderful to have you back with us for another episode with Sit Down with Sid podcast, where we bring people together one conversation at a time. A quick note before we begin. MH370 remains a complex mystery with many conflicting theories. The views expressed by our guests are their own. Our goal is to provide a platform for various perspectives as we continue to piece together this permanent digital archive in our MH370 series. Joining us today is Captain Shem Malmquist, a veteran Boeing 777 captain, flight safety expert, and a specialist in system safety and casual analysis. Captain Malmquist's extensive operational background brings a critical flight deck and socio-technical lens to understanding the complex automation and systemic factors surrounding the disappearance of MH370. Captain Shem, you have spent your career mastering the intricacies of modern aircraft and advancing aviation safety through rigorous systems thinking. You bring a unique level perspective to this mystery that very few can offer. It is a pleasure to have you here for this collaboration, and I want to thank you very much and welcome you to the show.
Yeah, okay, thank you for having me.
Of course. Okay, so Captain Shem, for audience members meeting you for the first time, could you please share a brief overview of your background for flying the Boeing 777 and what initially drew your professional focus into investigating the mysteries, especially surrounding MH370?
Well, my background included approximately 50 years of flying, as well as being involved in several major accident investigations and academic training in addition to that, which includes a doctorate in, really my dissertation topic was applications to support system safety engineering. The title is a little bit complicated, so I don't want to get into that, but basically system safety engineering was the focus and the topic of the dissertation for ways to apply system theoretic methods to understanding accidents and the factors involved. I don't have a particular experience. Of course, MH370 was interesting for everybody involved. Having been involved with investigations for a long time, and in discussions with other people that I know who are senior investigators, I think a lot of us have had very similar feelings on it, but obviously at this point there is a lot more we do not know than what we do know, and that's the bottom line, is that everything is uh, pretty limited without more information, without getting it, access to the flight data recorder. In particular, the cockpit voice recorder would be extremely helpful as well. But even the non-volatile memory that's contained in many of the other components would be really helpful. We don't have any of them. So it makes it very, very difficult to make any kind of good judgment. And generally, I would be very questionable for any assertions that just blame pilots, because that's super easy to do, especially in the absence of information, but generally wrong. So I guess that would be the where I am on the whole thing at this point.
Great. And we'll actually go into details in the later part of this episode. Okay. Now, from your perspective as a 777 captain, how do we evaluate operational limits such as the mode control panel, bank angle restrictions, the roll modes, and autopilot commands against the available flight reconstruction data to determine whether the maneuvers were human induced or were they system managed?
There Obviously, there are some limitations on what the autopilot can do in terms of rates of turn, bank angles, and things like that. Um, but in the end, there are external factors that can result in exceeding those. So we can't just look at those numbers and say categorically that it was one thing or another. That would be disingenuous for sure. There's not enough information to say one way or the other at this point. Um, in terms of that, but of course, the flight path seems a little bit erratic. So it does not really reflect the way an autopilot would necessarily fly the airplane. It doesn't mean a human was flying the airplane either, by the way. So we can't just assume that just because the autopilot wasn't flying it, a human was. That's not, that wouldn't be an accurate assumption either.
But let me ask you. So MH370 left Kuala Lumpur. It was on its routine path till Igari, where it made a sharp left banking angle turn. They say it's anywhere between 31 degrees to 38 degrees. And correct us, the autopilot on a Boeing 777 limits the turn to 25 degrees. So it has to be done manually. That is why I brought up the human intervention part.
Well, no, it does not have to be done manually. Just because the autopilot did not do it does not mean that, for example, and I'm not saying this happened, but as an example, an external gust, a encounter with a thunderstorm that banks the airplane over. There are a lot of possibilities that could happen that do not involve the human aspect at all. So just because the autopilot did, it might have exceeded limits of an autopilot. And by the way, in turbulence, it will exceed certain parameters temporarily while the autopilot is trying to control the airplane. So you really can't, that's not insufficient information to say that what was doing it. Um, probably it wasn't the autopilot, but you really couldn't say for sure. I mean, that would be extrapolating on evidence that's just not there.
So let me ask you, Captain Shem, and I'm sorry if I give you some pushback, because we've been covering this the entire year. Because when the MH370 made a sharp left at Igari, the flight path after that for some time was erratic. It wasn't flowing in single line, and as you also mentioned, and most of the hypothesis that of the guests we had on our show is that since it was flown manually at Mach 8, which is I think the speed, it's very hard to maintain an aircraft at like flight level 350. Um, so that is where I'm a little bit conflicted when you say
I
that.
would I would push back strongly against that. Um, so first, it's Mach you know, decimal 80 or 83, no nominal cruise for a 777. It's around Mach decimal 83 or so, or Mach decimal 82, depending on, what we're flying for fuel efficiency. At the altitude, yes, the air is less dense, and a conventionally powered airplane would be more challenging. With the fly-by-wire, it really isn't that. I mean, as long as it's working. But that's assuming the fly-by-wire was working at that point. If the aircraft had gone into direct law due to other associated failures, then that would make the airplane much more challenging to fly for a pilot that was, particularly a pilot that might not have been experienced, who would, a pilot that had been around a long time and had been hand flying airplanes or flying um, airplanes in those altitudes prior to the advent of reverse vertical separation minima or RVSM would have had experience and been able to manage it well enough. A pilot that came up later, like we saw with Air France 447, you have two pilots that are very, very competent, but they had never hand flown an airplane in that regime, and no training provides that. So all of a sudden, they were handed an airplane with degraded flight controls at the same time as they were put into a flight regime that has challenges. So a pilot that has experience probably wouldn't have a great deal of problems. However, once you go into direct law, then of course it would be a bit more challenging. But I don't think it would look like the way it did. Um, it would be not as precise, but it wouldn't be what looks more to me like a fugoid. The
Interesting.
period that is dipping and climbing is, you know, I mean, it's a much more closer to what we see with a fugoid type of motion and not the short period type of motions that you would see if the aircraft was being hand flown in direct law.
Interesting. And given the complexity of the Boeing 777 auto-flight system, what specific system behaviors occur when transitioning from a coupled lateral navigation mode to, say, manual intervention during the high altitude cruise, especially on MH370?
Well, if you disconnect the autopilot, then of course the autopilot may or may not be following whatever's in, the flight management system anyway. That depends on how you have set it on the mode control panel. But the airplane, if it is coupled to flying the flight management system, is following basically what we call the magenta line. If it is not following that, then of course it's free to go in any direction you want.
Got it. And how do the anomalous control inputs or, say, fuel management manifest in the flight data recorder parameters? And what can the recorded control surface deflections tell us about the state of the autopilot during the MH370's extended southern flight?
The control surface deflections themselves, you know, I guess I just need a clarification of what you're asking. You're asking me if the autopilot moves control surfaces differently than a person will. Um,
Yeah, yes, that is correct. That's what I'm asking.
well, the surfaces, the way the system works is that the autopilot, manually control takes the analog control, transfers it into digital, and then moves normally in normal flight control law via the flight control computers, which then translate it back into analog to move the control surfaces. The autopilot basically just going directly using its digital control, and and of course that has still have to translate into analog to move the control surface itself. Um, I don't think that there's not really a tremendous difference between those two as how it's going to manifest. You have Either way, the rudder is entirely independent, and the ailerons and elevators would be um, controlled, as I just said. So I don't think that you would have a significant difference unless you have a complete electrical failure. And at that point, things start getting different.
Okay. So it's great that you brought it up because, I, as you initially said, that we don't have the full evidence on surface to to say exactly what happened to MH370. Now, we had guests on the show with various hypotheses. This is all hypothesis. Hypoxia, human intervention, uh, the oxygen bottle rupture, which causes the electrical failure. Uh, in your understanding, based on whatever we have been presented till date, where does your theory stand to exactly what happened to MH370 after it made that sharp turn at Igalo?
Um, well, I would say that at this point we don't know. What it does fit, based and working with some other investigators that have said the same thing independently. Um, Lithium battery fires occur at almost that exact time frame in terms of after departure. A severe lithium battery fire could take a lot of components. Um, it would, if in that type of scenario, it would involve a pilot making a attempted turn back and then perhaps being incapacitated and the airplane just wallowing after that. So, so that's one area that I would be very interested to explore, just because on the other lithium battery fire events we have seen, there has been some similarity, and I mean, depending on where it is, it absolutely can take out a lot of systems and lead to similar types of things. So, but it's really entirely speculative at this point. We don't know. We don't have enough information to say. Uh, other than trying to put pieces together of different things. I would, yeah. And so I guess anything else that people are saying though are equally speculative. Claiming pilot suicide is just as speculative. In fact, I would argue even more so than that. So, so
Would
that
you
would,
No, no,
I
that's
guess,
great. Would you mind touching more on the pilot suicide? Because as I said, you also mentioned that is like kind of out of the question, and it's all speculation, But you strongly, if you want to push back on that for some of the people who believe that the pilot did it, what pushback do you have for them based on your understanding and experience flying 777?
well, there's just really no evidence to support it. I mean, that's all built around, a pilot having a flight simulator and various things like that. I mean, that's very, very circumstantial and weak. It's convenient. I would say that that is the most convenient explanation for a lot of the people involved, especially people in power, who have stakes to lose. That is an easy out. Oh, it's just pilot suicide. We don't have to do anything. That's not our fault. There's nothing to fix. If it comes out to be lithium batteries, well, that means our entire system is broken down. And it also would imply that something like that can take down an airplane in a manner such as this. So so that requires a lot more work and a lot more things to be done. Um, the Nobody wants to stop moving lithium batteries. It's very, very profitable. We don't want to say that it is something like that. Whereas, you know, blaming the pilot is very convenient for a lot of people that have other agendas. And so I would just say that there's just no evidence to support it in any tangible way that I have seen.
And then the waypoints on the simulator, I think there were two waypoints that were deleted. Does that mean anything from your
No,
perspective?
I mean if somebody is playing with a simulator and that's a hobby, and there's a lot of pilots that have that kind of hobby, they set up scenarios all the time of different sorts of, oh, what would happen if this happened? What would happen? Let's try to make something because flying a simulator is not very challenging. You have to build something in to make it so it's a little bit interesting if you're an experienced pilot. I had one simulator that I discovered you could fly underwater. Well, that made it fun. All of a sudden flying 500 knots under that, chasing the ocean floor, that was kind of exciting actually. So you need to have something unusual. You can't, if it's just no actual airline pilot is just going to do what some of these flight simmers do and fly, like they're flying an airline flight. That would be I mean, it would be super boring. What makes the actual flying interesting is there's weather, there's variations, there's, you know, interacting with the other members of the crew and things like that. I mean, that's what makes it more interesting. You know, Flying a simulator on the same route, simulators are predictable and boring. So why would you do that?
Interesting. And then how do the complex FMS, the flight management systems, and cockpit automation interplay during the non-standard maneuvers, uh, especially like the tactical flight paths, like that was analyzed in the MH370 disappearance, uh, when you're operating outside of the standard operating procedures?
Well, I don't know if I quite follow your
Yes.
question.
Yes. So, okay. So let me change this question to, when MH370 left the Malaysian airspace and went into the Vietnam airspace, there was a delay of 15 minutes, from the air traffic control. And I have asked this question to everyone, every guest we had on the show, and I'm going to ask you the same question. Does that raise some kind of red flag? Usually, the standard procedure is around 2 minutes of contact time where the traffic controller has to contact the airline. That's what I have read. Correct me if I'm wrong. So based on that additional 15-minute delay, do you do you see any red flags like something going on?
No, it's it's very, very common. I mean, especially, I've flown that exact route. I mean, there is nothing unusual about that kind of thing. If someone doesn't immediately call or check in or something like that, I mean, the assumption is, oh, maybe they got the wrong frequency, or they could be in just a spot where they're not receiving, and so you wait a few minutes and try again, and that's normal. There's nothing unusual there.
Okay, interesting. I want to talk about I know you had um, expertise in causal analysis, which is based on system theory. Given your deep expertise in that, uh, how does shifting our focus from component failure to inadequate safety constraints and control loops change our interpretation of the MFP70 event?
Well, it's really I would argue, the only way to look at it. If you're looking at component failures, first of all, when you look at software or humans, they don't fail in that way unless they die or you take the power out. They're still working. So the problem is not one of something failing, which is what the traditional methods look at, and then probability of failing, which is entirely contrived for humans and software. But instead, we look at what made it believe that it was doing the right thing at the time. And that goes for every human in the organization and all of the design decisions and the way the software is working, the way the human is working in the system. You're looking at, why did it make sense at the time? Or if you're doing perspective analysis, why would it make sense at the time? What is the scenario that you could say, you know, if if this happened, why would it make sense to do this? And so what we're doing, instead of looking at component failures, which also include a linear causality, which is only accurate in hindsight. We have a tremendous hindsight bias. We say, well, this happened. We look at the outcome and we have outcome bias. and we look at, a chain of events and say, oh, I can see all the events leading up to it. That's only true in hindsight. When you're going forward, there's infinite numbers of possibilities at each point. And so you can't, so using a chain of events type of methodology um, is going to lead you to incorrect conclusions where you'll say, why didn't they do this action? It does not make sense. Instead of thinking, okay, well, maybe they had more than one action to choose from, and they were picking one that seemed to be the best at the time based on the information they had at the time. It's a phenomenon known also as local rationality. What you believe and what makes sense at the time is much different than what it looks like in hindsight when you know the outcome. And so we look at the entire system that way, and it's not just individual humans that are doing that, but the way people work together as a team, combinations of decisions, which can be, individually, each of those decisions might seem safe, but in certain combinations, two different decisions could cause problems. We see it with with really every aspect or every part of an accident. So instead of looking at what happens in terms of time, instead we're looking at what control actions were available at the time and what ones were unsafe. In the case of an accident, there were unsafe control actions. And we go through every part of the system. So not just what the pilot made a decision of, but also everybody else involved, but also choices that the software made, the software made design or choices of control actions based on the requirements that were written into the software code, the reason for the code and how, or the requirements had to do with assumptions made on how it would operate, and the same thing for people. And so we make certain assumptions, and we have to base those assumptions on something else which may or may not be accurate. Most accidents occur due to flawed assumptions. Somebody made an assumption that something would happen in a certain way, and it just was not accurate. So we're looking at the entire system. We go up above the pilots, and you have the design of the airline, the organization, the decisions they made, and what controls they had in place to try to prevent certain outcomes. And then we go to the aircraft manufacturer, go to the regulators, and the different regulators, by the way, because there's multiple regulators involved, for example, in this accident. And we look at how they were all interacting. And in a causal analysis based on system theory, or a CAS, we try to understand why the controls that they had in place did not work, to get an idea of what the assumptions were and why those assumptions were not valid. So it's a much different approach to accidents than is traditionally used.
Interesting. And then why do you think in case of MH370, why did traditional investigations fail to capture the, as you mentioned, the dynamic human operators, the software and operational policies? And how does the system theory actually bridge this entire gap together?
Well, traditional investigation, basically, you're going back like kind of through a chain of events. And first of all, you're saying, oh, this chain of events broke. So that's our factor. That's our cause. That's our probable cause or root cause, which is just as bad. And we pretty much stop there. Usually it's just at a convenient point. The difference with system theory is that you have to look at what factors went into that decision, which requires not just understanding why an individual might have made a decision, or the decision somebody made at the time, but also you have to understand the controls and pressures that went into those other people that were involved. For example, take a pilot. is not making a decision in a vacuum. Their decision is based on their training, on their experiences, on their, the policies and procedures and the regulations. They have all of these things going in, which are constraining our, really the options that you have. So a pilot only has a certain number or a finite number of control actions they can make at any point in time. And some of the control actions are going to be prescribed in advance through policies and procedures. Other available control actions might be based on, circumstances that come up that were not anticipated, which humans are able to adapt to. Software is not, by the way. Software does not adapt to novel situations very well at all, but humans do. And so we take in new information, but within those available control actions, we can say, okay, these control actions will have a safe outcome. These control actions will not. This combination of control actions could lead to something unsafe, where something else is not. And so we can be extremely complete in understanding all the nuances that went into an investigation. And in a linear chain, what happens is that you end up focusing often on a certain part. The other part with linear investigations is that they tend to enable, or at least not inhibit, bias on the part of the investigators. We talk a lot about the individual heuristic biases that might occur that might cause flawed decision making for an operator, but we don't really think about it in terms of the investigator. The investigator themselves has their own biases that are coming in, that they are making presuppositions and they're building a case around it. And so one of my concerns is this linear type of looking at the accident tends to result in a focus on the easiest stopping point, which is the pilot. And a lot of focus goes in there. And it actually, through confirmation bias, ends up resulting in people not looking at alternative explanations as much. Now, some alternative, things can be just silly, or extremely improbable. You can probably say it's unlikely that they were hit by a meteor. Now, it's not impossible, but it is unlikely, right? But other ones, or space aliens or something, those things are, get to be to the realm of silliness. But we, at the same time, you don't want to focus in and just assume, oh, well, it has to be pilot error. Most accidents are pilot error, which is not true, by the way. That's also really, it's a myth based on looking at the probable causes of accidents that blame pilots, where arguably most of those accident reports are flawed. Just going to say it's flat out. Most of them are not accurate. They are the result or consequence of bias in the investigation process itself. And all sorts of things can cause such weighting. As an example, if the people doing the investigation are given a pilot's training records, for example, which happens very early in the investigation, and the portions of the investigation team that are given those records are the people that are the former pilots mostly. Well, those people don't have any special training. They're usually pilots that didn't continue flying. They could be retired, or they could have had a medical issue, things like that. And they're perfectly competent. But what happens is when they get these training records early on, and if they find that there was ever a training problem in the past, they go back and start building the entire accident through that lens and looking for, oh, maybe this pilot wasn't very strong, or maybe they had problems here and there. And that can lead them completely astray. And that's my concern of a little bit of what's happened here with the idea that maybe there was mental health issues. You take a little bit of a piece of it, and that anchors their viewpoints. So the lens that they're looking at the rest of the accident is looked at through that lens. And it becomes very hard to overcome that kind of momentum once that happens in an investigation. So, so it could be. I'm not saying it's not, but at the same time, I would not assume that it is either. It's, we need to um, just say that the absence of evidence that it's not doesn't mean that it is on any of these accidents. And pilot suicide is a pretty rare event. I'm not saying it doesn't happen. We know it does. And that leads to an entirely other um, exploration if you're using system theoretic methods, where you have to understand how did our system get set up that allowed that to occur in the first place? Why didn't we have controls in place that caught that? So that's a whole other area that should be explored. So all of these avenues right now, when in the absence of more concrete information, could be explored. We don't need the airplane to be really understanding that system and improving it. We can improve the systems to mitigate the risk of pilot mental health. Simultaneously, it does not preclude us from going back and saying, okay, what if it wasn't? What if it was lithium batteries? Well, we can go in and we can develop controls to mitigate that and make that less of a risk. Or, some other possibility, convective weather or something like that. We can develop controls for all of those things and redesign our system and make it safer regardless of the outcome. And then, we find the airplane at some point, we discover what it was. All that other work is not for naught. We have actually still made the system safer. And that, I think, in the end, is the ultimate goal for accident investigation.
Very interesting, very interesting theory you have here, actually. So let me put the spotlight on you for a second. So let's take the linear investigation part of which you, as I said, which has been taken in conclusion or taken in uh, record for the MH370. If you were to be given the task of investigating MH370 based on the system safety and casual analysis approach, how would you approach the MH370 mystery, coming up with some kind of, say, assumption, hypothesis? I'm very curious to understand your breakdown of the investigation, especially when it comes to MH370, based on what you just shared.
Well, I would start, um, I would do a causal analysis based on system theory. I would start at the bottom of what we call a control structure, a hierarchical control structure, and the basic process being controlled, which is the aircraft itself. And I would look at the controls that are available to the aircraft, and then I would examine each of those controls in how could one of those controls be unsafe. And from there, we don't know what happened. So we can't say which ones were applied or which were not, but we have now limited the scope to the controls that could be unsafe in that context, in the particular context that the airplane was in at the time. Obviously, the pilot has controls over, the landing lights. That's obviously not going to be a factor, right? So we don't have to look at every control the pilot had. We only have to look at the controls that in the context of where the flight was at the time could lead to an unsafe outcome. And those would be the first avenues of control. And then you take a look at each one of those controls that could be unsafe, and you understand and you examine why might it make sense for that unsafe control action to be made. And you don't start with any presuppositions at all. So each control, you look at all of the mental and physiological causes, cultural factors, all of those that could be leading in, but you also have to look at what sort of information, what sort of feedback did the pilot have at the time? What sort of, or the autopilot. I'd actually be starting at the autopilot even before that, or the electronic flight control system, or, which is the fly-by-wire system, which is below the autopilot even. And we look at each one of those and say, okay, what control action was made? Why might it make the wrong control action? Did it lack feedback? Did it think it did a control that didn't get to whatever it was trying to control, the process, which in, a flight control system would be, a control surface. And we go through each one of those. Maybe a control was made and the airplane did something anyway. That's an example of turbulence. For example, a pilot or an autopilot might be trying to turn the wheel to the right, and the turbulence turns the airplane to the left. That's another way that these things can happen. And we do the same thing with every controller. So we start with the flight control system, then the autopilot, and then we'd examine the interrelationship between the pilots and the first officer. Then we go above that, and we also look at other factors. One of the things, of course, with the flight controls is maybe the pilot was doing whatever they could, but they couldn't work because they didn't have power, or they had partial power due to the way, like a fire propagated or something. So you'd be looking at all those things as you worked up. And then, of course, to the pilot, the training, the circumstances, and, we look at the airline, the manufacturer, the regulator, the entire framework to understand things. And of course, one of the scenarios would be, potential for a pilot suicide. So then we would be looking at what are the controls in place to keep that from happening and understanding that. And then, of course, the other direction that we've mentioned, and there may be others, is, maybe a fire. So we'd look at what are the controls in place for that. And what we'd end up with initially is a lot of unanswered questions. So we would say, okay, there's a possibility this happened. We don't know, so we have to leave it as an unanswered question right now, and put it and just jot it down. But at this stage in the investigation, I would treat each one as if they could have happened, and then still develop recommendations and mitigations to each of those possibilities. So now you have things out there that are tangible, that are, completely agnostic to what actually happened for the accident, but they still are very valid safety recommendations that you can make the system safer. So I would take an entire holistic safety approach, looking at the entire socio-technical system to understand ways that we could prevent something like this from occurring, regardless of what the actual factor was, since we don't know at this time.
Very interesting approach. It's something new that I've heard, and just putting things together in my mind. It seems to be a very complex, if is that the right word, if I'm using a very complex approach to investigation?
Well, it's a way to investigate complex accidents, which this is, but in actual fact, once people learn it, it's actually often simpler way to investigate accidents, because instead of, well, I'll give you a simple example. Say a car is driving and hits a car in front of them. So we'll exclude, just for keep it shorter, the ability to steer away from the obstacle, and just say, let's take a look at brakes. So you would take a look at the brakes, and in a traditional investigation, you would just basically have to brainstorm and think about all the possibilities. And you may or may not be complete. You may think of every single possibility, or you might not. If you're using causal analysis based on system theory, instead, we would say, okay, what are the braking control actions? They can apply the brakes. You really have a couple possibilities. So applying the brakes is a control action. So is there a scenario where applying the brakes would lead to a hazard? Well, there is one actually, right? It could have a big truck right behind them. Or it could be really a slick road. Applying the brakes could actually cause the car to lose control. So it's another possibility. And there's other ones as well. So you look at those. Then, of course, there's cases where not applying the brakes can lead to a hazard. You can look at applying the brakes too strong. too little brakes or too much brakes. In the case of an icy road, too much brakes actually could be more of a hazard than too little, right? So you can look at those. You could look at applying the brakes too soon or too late, or applying them for too long a period of too short a period of time also. And you look at each one of those possibilities. In the case of hitting an obstacle in front of you, in the traditional way, you would just kind of brainstorm or probably come up to a quick conclusion, oh, the driver just made a mistake. But in this case, you're saying, why did it make sense for the driver to apply the brakes the way they did? And it could be that there was a truck. What did they believe? And they were taking that as a lesser of the risk. Um, or they believe the road was icy when it was not. That would change how they're doing it. So now you have things that make a lot more sense for why the driver chose that decision. And once you have that, you can make much more tangible recommendations by understanding why did it make sense for the driver to do what they did. And really that's the way we approach the entire investigation. So it's a much different approach than is usually used. And it actually simplifies it. In fact, looking at the control actions, we know every single possible control action that would have changed can affect a particular, accident under given circumstances. We can map every single one of those as 100%. We know every single one. We know every control the driver has. We can look at it. We also know that there's only 4 ways a control action can be unsafe, which I just mentioned earlier, but not applying, not providing it too much, too little, too early, too late, the wrong order, or too long or too short. That's mathematically complete. We have now mathematically captured every single possible control action that could be unsafe. So now it comes down to analyzing why it would make sense for somebody to do it. Well, that is much different than trying to brainstorm all the possibilities that you do in traditional analysis. So although the traditional analysis seems simpler and definitely kind of fits with our basic causal, narrative that we grow up with, it actually is a more messy process. This is a mathematically complete process and is much, much more powerful than other methods.
Very interesting. I really find the way you are taking this, it's a very unique and different approach I've never heard before. So, and I'm just trying to wrap my head around it. But in order to understand the control analysis and all that you're mentioning, you need the body of the plane. Like, how do you? So my question to you is, in MH370, how do you do what you want to do without the wreckage, without the
Well,
plane itself?
we don't need the wreckage to know what control actions were available to the pilot at the time, right? And so we know all the controls that are in the airplane, every switch, every button. We know what those are. We know the ones that would make a difference, like, pushing the button for the cabin crew chime is not going to have made a difference, right? Probably. Well, maybe it could have, I don't know. But yeah, but there's plenty of controls on the airplane that would make no difference at all. And anyone that could have made a difference, um, that is the something that we would then analyze and consider and follow up. And it's going to be it would change the investigation to be, instead of just something that had happened, which is a causal analysis based on system theory, it would change it into more like what we do for prospective hazard analysis. When they're designing a new airplane, you need to look at every single control in the context, look at every single way it could operated. And if you're using traditional methods, they're linear and limited, and you're going to miss a lot of things, which we saw, for example, with the Boeing Max, using traditional, what they call the ARP 4761 and 4754 methods, which are limiting. They're linear. And so a lot of brainstorming is involved. You're going to miss certain things. You're going to make assumptions that aren't valid, because they're probability based. And I didn't mention it earlier, but probability itself requires assumptions to be met in order to use probability. When you see a distribution curve, which is what probability is based on, that distribution curve is based on certain assumptions. One of them is that what you're looking at is going to display normality, and the other one is that each data point is independent. Well, as soon as you add humans or software to the mix, it's not independent. Everything is contextual. And so the entire assumption that probability analysis is rests on is invalid if you're using it to analyze humans or software. And if humans and software in your system, you can't use it. It's very good for looking at electromechanical components. We can use it for that, but not for humans or software because they're going to behave differently in every single circumstance, and you just can't use that kind of method. So so what you would do instead is use a system theoretic process analysis. And system theoretic process analysis is something that we look at all of the available control actions in a particular context. For example, if you're taxiing on a taxiway, the control action of moving the pilot elevator controls or the ailerons don't make any difference to a big airplane. I mean, a little airplane they do for other reasons, for if there's winds, but for a big airplane they don't make any difference. So we don't have to analyze them if you're looking at a taxiway issue, right? Brakes and steering matter. That's really it. But the in flight you have another set of controls that matter, and we can analyze each one of those. We can then look at how each one could be unsafe in the particular context. And then we develop what we call causal scenarios to say, why would it make sense for a controller to do this at this particular time? And by the way, we can also analyze physical components, but it's a little bit different. Instead of saying, what's the probability this will break? Instead, what we're doing is examining the assumptions that we're making and looking at building scenarios and saying that the assumptions might be violated so we can design them so they won't break. So it's a little bit of a different approach for hardware. But for humans or software, we're going to try to understand why it would make sense at the time for a controller to do something. And once you have all those scenarios, designers can find ways to design them out. And so it's a different approach. We don't use probability at all. And so I would take the accident when you don't know the outcome, and I would treat it more like that, like as perspective analysis, and look at all of the possibilities using system theoretic process analysis to develop a whole number of scenarios of how it could have happened, and then mitigate all of them. Because why not? You have now identified something that could lead to an accident under some circumstance. It might not have happened on this accident, but it could happen on another one. And so why don't we just mitigate it in advance now that we found it? So it makes much better use of the investigation time, as opposed to trying to build a case around, a suicide or whatever else it is.
Interesting. I have one more question on this and then a couple of questions before we wrap this up. So I know you had mentioned when I brought up the hypothesis or speculation where you stand, you had mentioned fire, the lithium battery fire, which was in the cargo. And one of the famous journalists, I won't name that journalist, had actually made the same assumption. And that person is a prominent journalist in MH370. So based on the approach that you said, the causal analysis and systematic, how did you come up to say the lithium battery fire speculation hypothesis? Did you take those things in like, did you take those things in control while making this assumption? Or I'm just curious to understand where did that come from?
That actually didn't come from that. This was earlier on.
Got
It
it.
was really, I was looking at that airplane suddenly has control problems just a little bit after top of climb. And whether you're looking at the UPS accident, was it the China Air 747? I mean, they all happen right around the same time. The lithium batteries, something happens that there's a problem, but it's not manifested until about 20 minutes, 25 minutes into the flight, something like that. Right around the time the airplane levels off, seems to be what it is. And we've seen it enough times now that it just, I was thinking, okay, well, if you get a fire right then, fires can do bad things and lead to um, a lot of problems. And I happened to be actually right after this happened, I was at a event with the International Society of Air Safety Investigators, and we were sitting around with several um, investigators in charge for different government bodies, and pretty much everyone at the sitting in the lounge area was kind of felt like that was kind of made the most sense to them at the time. So it was really, I think everyone just kind of was thinking the same thing because these lithium battery fires seem to happen right around that phase of flight. So it just kind of fits it in that regard. But really no other evidence to go on other than, I mean, at that time, I didn't even know if there were lithium batteries on the flight, which of course it turned out there were. Um, but it just fit a lot of the parameters. And so it was really just something as simple as that.
Perfect. Thank you for clarification. Now, since you brought up international bodies, I have asked this question to every guest, and I'm going to ask you as well. Based on the competence level, including the United States, the Malaysian, the Chinese officials, I have heard even Saudi. What do you think? Do you think was the investigation or is the investigation done in a very competent manner, or do you see some loopholes based just on your understanding?
I would, well, rather than critique them, I'll just say this categorically. Every accident I've looked at from every single country that was not done using causal analysis based on system theory, I have found significant gaps. And and very commonly completely different conclusions. So, I think the investigators themselves are very competent, um, but they are limited by some of the tools. And developing something much more robust, which a few of the governments are actually now doing, would lead to, I think, much, much stronger understandings of accidents, not just in aviation. This applies to pretty much every domain you look at. Um, they tend to be, um, they tend to miss things simply because the methodology leads them in the wrong direction, results or just ends up being incomplete, and so they don't consider certain factors. So I think that that is the biggest thing I see, and I'm not going to say that any of those agencies, they're very good. I have a lot of friends at most of them, and I know the people involved, and so they are good. But the methodology just is going to leave gaps. And so as we start seeing more countries adopting the newer methods, we're going to start seeing better and better investigations. But some of them are still very good despite that, and that's really because the investigators are so good that they can see through the methods and find things in addition. But we've just found over and over again that we can be more complete by going back and looking at these investigations again. Even ones that seemed really simple come back and we discover things. So it's been a very interesting process. I do that with my students all the time. Um, we have them work on an accident that's been done, and do a causal analysis using system theory. And I try to limit them so they're just using the factual portions of the report. So I try to find reports they're not familiar with, they don't know the outcome. And then at the very end, I'll provide them the full report and have them compare it. It's very, very interesting. But the students often will find much more just based on the early preliminary technical factuals than the final report did. And it's just because the
Right.
methodology is going to force you to consider things that you otherwise would not have.
Very interesting. And I just want to let our audience know that we have the link of your website as well as your Florida Institute of Technology link within the description. So if they want to read more about you, reach out to you with any technical questions, please feel free to do that. Couple of more questions. One, I want to talk about the wreckage. So once again, a lot of hypotheses. It was controlled ditching. It was high-speed crash. There were mostly the debris from the outer part of the airplane that were recovered, except the entertainment console and I think one of the bin from the inside. Now, based on what we have till date on the wreckage, what is your theory? Was it a controlled ditching? Was it a high-speed dive? Did the plane disintegrate it in the air before touching the ocean? Give us your 2 cents on this, please.
I I actually don't. I would say that I'm agnostic to whether it was. I would say that I wouldn't say the airplane was under control, but whether the airplane was just kind of wallowing along and then like kind of gliding and then hitting the water basically in a pretty flat way, or whether it somehow nosed over or knife edge. Um, I mean, I think either of those are equally possible if there were no pilots at the control or the pilots were unable to control the airplane. Um, you take a landing in the ocean, and even if you have the most skilled pilot, we have, of course, a famous Sully accident, but he was very, very lucky. 1 degree of roll either direction, the airplane would have caught and cartwheeled probably. And in the ocean, they almost always, even if it's controlled, the airplane usually ends up cartwheeling and just breaking apart. So there's really no way to know. It's that I would say based on that, one way or the other. I think there's insufficient information. We don't have enough information to go on.
Interesting. And what do you have to say about Ocean Infinity, who have conducted multiple searches since 2014 and have still not found anything? Do you think are they looking in the wrong place? That's my question to you.
I I don't know if they're lit. I would say that we don't know. The problem is at this point, all of the transponder and the signaling, the emergency locator transmitters would be long since dead. And even before they were dead, if the airplane was down in like an underwater, canyon or something like that, you'd have to be right in the right position. It's underneath the thermal layer. The water's deep. The penetration of the signal is not going to be very far. So, I mean, you can definitely be right over it and miss it. It took them a long time to find Titanic. So I can't say that they're in the right or wrong spot. I really, really hope that we find the airplane. I think it would really go, you know, put all this to rest. That's all I can say about that.
Wow. Well, Captain Shem, this was actually quite a fascinating and interesting conversation. Some of the things
Yeah.
that you've told. And as I said, if I try to put my head around it, to me, it seems like a very complex process. But as you said, this is a complex scenario. So that could make sense.
Exactly.
Uh, Anything you would like to add before we wrap this up? If anything you thought we missed on or something, please feel free to.
Well, I think that the only thing I would like to add in general is that I hope more organizations start adopting these newer methods that are based on system theoretics developed by Dr. Nancy Levison from MIT. They can Google just the word stamp, like postage stamp, MIT, and then they'll get into the website and they can start learning a bit about it. Although I would caution against just applying it without some training. Um, there is it's not a difficult one to learn, but it is one that you can easily end up in the wrong direction without training. And it is a real paradigm shift for a lot of people, and that makes it more challenging. So I would say that more people should start applying these types of methods to have a much better understanding of accidents and hazards in general. And through that, we can literally, as Dr. Levison says, um, engineer a safer world. And that's really the ultimate goal.
Interesting. Well, thank you so much, Captain Shem, for your time. And I just want to ask our audience to um, please share this episode because in the world of fleeting digital noise, our collective attention is the only thing that keeps the search for the truth alive. By listening, you ensure the story and the 239 souls it represents are never fully lost to the deep. Captain Shem, once again, thank you so much for taking the time. And we look forward to the audience feedback and keep doing what you're doing. Thank you so
Yeah.
much.
Well, thank you.
Thank you. Take care. Bye bye.
Bye bye.